see. Okay, let's the recording begin. Okay, the recording has begun. So let me start by sharing my screen and then we can proceed. Okay, so I think you all can see my screen, which is shared in here. So let me discuss the assignments for week 2. This is from the previous year's course. So this week 2 assignment has some of the basics of getting started with C, and hopefully I'll be able to discuss the key topics in here, and this is going to clear up the concepts and will let you do the questions which are asked for this year. Okay, so which of the following is not a C variable? So as you can see in here, there are 4 options. Obviously, you can name a variable like this, like all of these, except for the value, the thing which is here, which is the option number C. And we can test this. So for testing this, I will use VS Code, but you can use anything that you wish. So let me create a variable. So this was like a print statement. This is like a normal hello world command thing that I have. So I'll just create a variable. Say I create a variable count 1, 2, 3, and let's have for default this variable be int. So I'll have this. Say let's call it 5, and I'm now going to print this. So let's say. So let's do a printf of this thing. Oops. Okay, so let me have this written like this. So what I'm doing is I'm just printing this variable. Okay, this is an unmatched bracket. Okay, done. So let me see if this program works or not. For that, I'll just hit run. And you see, count 1, 2, 3 equals to 5. So this is working. So this means that this is a valid variable. So you can look through the uh, videos of the lectures where you will see that there are certain rules with which are allowed for creating variable names, and this is one which is allowed by those rules. Okay, so let's see. The other one is count underscore 1, 2, 3. So this is also a valid name. So let me just make this count underscore and let me again hit run. Oops, let's see what happened. Something happened in here. Okay, so I have to change it in here as well because I've not changed the name of the variable. That would obviously give rise to an error. So now I think that this is fine. So let me run this once again. Yep, so now see, things are running fine. So this is also a valid variable. Similarly, let's try the other one as well. So let's do this. This is better in terms of showing the two things together. Okay. And let me, I don't know if I can make this small. Just a minute. Yes, I think this is okay, I guess. Yeah. Okay. So let's come in here and let's now try the next one, which is count @1, 2, 3. So I'll replace underscores with right. And now let me hit run. You see there is an error which is happening, and the error is syntax error, as you can see in here. So there is a syntax error in here, and this is because this is not valid. And you can also see in here that it says that there is this syntax error. This is happening, as you can see. It also marks right. So we'll just change this, add to a different value, which is this one, and this is also like a valid variable. So let's try this as well. Right, or okay, no, right? And now let's change this to something like this. And let's also right, and let's see. I'll now hit run, and again you see this is running fine. So this option C is the one which is giving you the error, as you can see in here. Okay, so now let's move on to the next one. Well, let's see what is it. It shows that, I mean, what is a function? So what is the definition of a function? So it's a block of statements to perform a specific task. Obviously, when you write a function, for example, main here is a function, right? So it's a block of statement that is performing a certain task. It's a modular unit to perform some tasks. So it's modular. So obviously, you can call it from anywhere. So it's like a box. Every time you call main, the entire thing is called. And has the same name and can be used multiple times. Obviously, you can use it multiple times, but main is a specific example. I will show you one function, and you see that you can use the function multiple times, and also as a name and can be used multiple times. So that's what it is, and then it is obviously used to perform a certain task. So for demonstrating this, so the answer to this, just to be specific, is all the options are above are true because a function does all these stuffs. So I can show this to you as well in here. So let's call a function int square. This will do nothing but give the square of a number, right? And right, so I get a number x and I return x times x, right? So I am now going to call it. So let's define a variable. Define num equals to 5, right? So now I'm just changing. Let me print square, and let me do this square of d equals to percentage d, and then I'll call here num, right, is square of num, right? Let me do this, and there let me create a variable. So I'll have int num in here, right? And num is 5, so square of num is this, and then now I'll change num to something else, right? So let me do that as well. So I'll do num equals to 8, and then I'll just print the same thing, that's square of num. So here you can see that this is the modular block. So every time you call square, this thing will be called. And so the first part is right. So this is a block of statements to perform a particular task. It's a fundamental modular unit to perform the task. So this is the unit with which you perform the task. And this has a name, which is square, as you can see in here. And you can call it multiple times. So we have called it 2 times with 2 different values. So first will give you 25, and the second will give you 64. So let's test this. Let me hit a run. Yep, fair enough. So you see, hello world, you have square of 5, which is 25, and square of 8, which is 64. As you can see, I'm highlighting in here, right? Here. Okay, so this being done, let's move on to the next one. Here you see the execution of any C program is. Obviously, here you see that the execution of any C program is sequential. So C doesn't execute parallel or multi-threaded, so sequential. So this is like a fact about how C programs are running. So C programs run sequentially, if every line at a time. So first line 8, and then line 9, then line 10. So it's, and then that thing goes on in a sequence. So that's what you have in here. Okay, syntax error. When does syntax error occur? I think this is something which is fairly straightforward, that whenever you violate the rules of grammar, then only what you have is a syntax error. When statements have no meaning, yeah, you can obviously write statements which don't have any meaning, but it's up to you for the programmer to decide what has meaning and what doesn't. The language is not going to tell you that, okay, this is what you have written, which doesn't make sense. The language is only going to see that if it has some rules and basic rules of it. If you are following the basic rules of it, then that is it, right? So you can say anything in English, right? And it is perfectly fine for saying any sentence in English which follows the grammatical thing that you are saying. But whether what you are saying has any meaning or not, that depends on what you are saying, to whom you are saying, and in what context you are saying, right? So it's up to you or up to the person who is listening to make sense that whether what you are saying makes any sense or not. But as far as the rules of the grammar in English is concerned, you can say anything and it is no problem with that as long as you follow the rules. If you do not follow the rules, then only there is a problem, and that in terms of programming is a syntax error, as you can see in here. And then next one gives an undesired output. Okay, so this is a different kind of error, and this is not a syntax error, but this is a runtime error. So when you are compiling something, and if you do not follow the correct syntax, then what you have is a compile time error and or a syntax error. Syntax errors are always determined when you are compiling a program. Your program won't compile and create a binary when you have a syntax error. While when you have a runtime error, your program is happily going to compile. And later on, when you are running the program, if you have some undefined behavior, then that gives rise to a runtime error while the program is running. For example, you take a number from the user, you take two numbers from the user A and B, and you divide A by B. And if for some reason the user gives the number B to be 0, then you have a divide by 0, which is not defined, and hence you have a runtime error. However, for any other values of B which the user gives, the program is happy to find out, and you do not encounter an error, right? So the program is going to compile for the specific case. But you will encounter an error when the program is running with the choice of B, because you are doing a over B, A by B, and then that will give you an error. So that's the runtime error. So to summarize, the point here is a syntax error occurs when the rules of grammar of the programming language is violated, which is option A. Okay, and let's come to question 5, right? Let's see what this question says. Here it asks that an integer needs 2 bytes of storage, and then what is the minimum value of the signed integer in C would be. Okay, so how this works is that this is, to be specific, this is not an integer but a short integer in C. Okay, but it has told you in the question that the variable or the integer variable has 2 bytes of storage. So each byte corresponds to 8 bits. So 2 bytes would correspond to 16, right? So that's what you can see in here. So you have 16 bits, and in each bit, so let me open the whiteboard. I don't know if you can, if I'm able to do that or not. Let me see. I think I have to unshare the screen and again reshare it. Where is it? Reshare. Yes. Here it is. So let me stop the sharing and let me share a whiteboard just to demonstrate what I wanted to talk about. So let me make a new whiteboard in here. Okay. Next. Yep. Nothing. Let's have a blank whiteboard. And okay. So you see, so imagine that this is a placeholder where you are putting the program, right? And I hope you are able to see my whiteboard. Okay, stop sharing. Let me see. Share the whiteboard. Yes. Not now. Okay. So here what you are seeing is this. And this is one such thing where I'm trying to make a bit. So each of this bit is, you can think of a elementary block in memory where a number is stored, and the number that is stored in here is either 0 or 1. So, okay, I think this is a bit confusing. So what I'll do is, in each of these bits, the number that you can store in here is, let me take the pen. Okay, choose a different color. So here you will either have 0 or you will have 1 at a time. So an example would be, say, 1 0, 1, right? So in this specific case, as I was saying, that you have different examples of what numbers you can set in here. So for example, 101 is an example. Similarly, you can have other numbers like 1, 1, 1 is another example of what you can set in here, right? 1, 1, 1. And therefore, if you have 16 bits, right? So because this is 2 bytes corresponds to 16 bits. And in each of these, you can set either 0 or 1. The total number of combinations that you will be having is 2 to the power of 16, right? These are the total number of combinations. But remember that what you are now having is an integer. So integer goes from negative quantity to a positive quantity. So you will have to span the entire range, not just positive, not just negative, but both negative and positive, including 0, right? So then half of this range will be occupied by positive numbers, and half of this range will be occupied by negative numbers. So this gives you a value of around 2 to the power of 15, right? So you'll have a 2 to the power of 15 negative numbers and 2 to the power of 15 positive numbers, including a 0, right? So let's see. So now this is also therefore the maximum value that is possible in terms of the modulus of the quantity, and so the positive, okay, so the positive number also includes 0. So the maximum value that is possible for you will be, and let's also take the minimum value, right, which doesn't include the 0. So the maximum value that which includes the 0 will give you 2 to the power of 15 minus 1, while the minimum value is minus of 2 to the power of 15. And then therefore you will have the span the entire range, which is 2 to the power of 16. So this is the entire range, but you divide into two parts, one positive part, one negative part, because it's an integer and there is a 0 in between. The 0 is included in the positive part. So therefore you have 2 to the power of 15 minus 1. That's the maximum value, while the minimum value is minus 2 to the power of 15. And what is minus 2 to the power of 15? So let's also find that out. For doing that, let me, I mean, you can also do this in uh, your computer, but I mean, let me use, you can just do a Google search as well to get this, but let me just use the math module. So this will also be, okay, let's not go into the complications, and let's just find out what is the value of 2 to the power 15 is. So I'll just give you 2 to the power 15. Sorry, I missed the 1. And you have 32768, right? And fair enough. Here you see it's minus 2 to the power 15 because it's a negative value. So minus 32768. So that's the accepted answer. Where the correct answer is D. It's remember, it's not 32767 because 0 is included in the list of positive numbers and not in the list of negative numbers. So therefore, the maximum value will be 2 to the power of 15 minus 1, while the minimum value is minus of 2 to the power of 15, and that's it. And this is what you have in here, right? Okay, so let me close the whiteboard and start sharing my screen once again, right? Okay, so this is what I was saying. So minus 32767 that you can see in here. This is not the right answer in this specific case because, as I was saying, negative numbers are not included. In the negative number set, 0 is not included, while in the positive number set, the 0 is included. So in the maximum value, it's less than, it's less by minus 1 from 2 to the power 15. So you have the maximum value is 2 to the power 15 minus 1, while the minimum value is minus 2 to the power 15. So the correct answer is 32768, right? So let's move on to the next question, question number 6, where you it asks, it gives this code and then asks what would be the result of this. So let's try this. Let's try to put in this code. Okay, so let me get rid of all of these. You see, it has a equals to 9, and then it has. Let me also get rid of the square thing which I was using for demo. It has printf, %d, comma a. So this is what it looks for, and this is it, right? So let's try to run this, and you see, fair enough, there is an error. And let's see what is the error in here. Okay, so let's try to put this in backhand, and let's see, undeclared identifier. So it says that, you can see in here that the error A is undeclared. And fair enough, because I have written A equals to 9, so the compiler doesn't know what type of variable it is. So it directly assigns 9 to A without creating A, right? So I'll just abort it in here and just give int A. So this corrects everything, and now if you run it, you see it ran successfully and gave you the value 9 that you can see in here. So this is, so the correct answer in here is a compilation error. That's what you will get, right? So let's move on to the next one. Let's see. So it defines hash define. So hash define, these are compile time arguments or flags that you can see in here. So let's, these are compile times flags, which is used in here. So you see hash define fun of x, which is x star x, right? So at what happens in here, okay, let me plus write it and then I will discuss this. So let's do float I, okay, so let's do this, float I, what more? There is this printf point to f I, right, and return 0. And then there is this I equals 0 divided by fun 2, right? And let me save this and let me run this code, right? So you get 16.00 because, so let's walk you through the code. And so obviously you can see the correct answer is 16.00, but let me walk you through the code and tell you what's happening in here. So you have float I, right? And what this compile time flag, which is, you can see fun does in here, excuse me, let me take a small break. I'm feeling a little bit thirsty and then I'll continue. Okay. So let's see. Right. Let me go back to this and open up his code for again. Okay. Great. So what you see in here is this fun thing. So this is a compile time evaluation. So what the compiler would do, that every time it will encounter fun with this argument, whatever the value of x, it will replace this with this. So all it is doing is replacing, it is not evaluating. So what the difference between this and the function which one would define is that a function is where the code goes during runtime and it is called, while in this specific case what's happening is that during compile time itself, the compiler is replacing every time it encounters fun with whatever you pass in the bracket with this, which is x star x. So what it is doing in practice for the compiler is that it is doing 64.0 divided by 2 times 2, because that's what you replace it with, right? So this is what it is giving. So it gives you 64.0 by 4. So this is 16.00, right? So that is what is happening in here. So let me again reiterate this, that whenever you give a hash define, you know that this is something which is evaluated at compile time and not runtime. While in the function, you have a block of code to which the program goes to every time that function is called during runtime and then evaluates everything. While here, what you can see is that all that is done is that every time you call fun in your code, the compiler during the compile time itself, it's not during runtime, during the compile time itself replaces fun2 with within parenthesis x star x or 2 star 2. Okay, and then the rest is simple. What you have in here is 16.0, and now this is percentage point 2f. So this means that you print an integer not integer, but a floating point number with 2 decimal places. So that's why you have 16.00, because you ask for 2 decimal places and you print I. And the reason it's 16 is because 64 by 2 square, which is 2 times 2, 4. So 64 divided by 4 gives you 16. I think this is clear to all of you. If not, please ask. Okay. So now let's go to the next question, which is question 8. Here you see that's following the C program swaps the values of the two numbers without using the third variable. Okay, so let's see what happens in here. So you see, let me write the code and then we'll also analyze what's happening. Right? So let's see, int A equals to 2, B equals to 3, right? And printf what the values before swapping, values before swapping A equals to percentage D, and similarly B equals to percentage D. Let me give a /n as well, because I want to print this in two separate lines. So that's why I'm giving /n, although it's not there in the code. A comma B. Right. Please ask me if you have any questions and interrupt me at any time. Right. So let's see. And then the blocks of code that will be running will be there. And after that, there will be this thing once again. And this will be after swapping. Right. And let me give it TER after swapping A and B. I'm printing it once again. So let's try each of the options and see which one works. Right. So let's do that. In here, let's see the first one. First one says A equals to A minus B, right? And then B equals to A minus B, B equals to A minus B. So first I'm just blankly showing you what will happen if I pass each of the options one at a time. And then we will go into explaining why the one which works, it works, right? So, okay, so let me just then run this. Okay, so you start with 2 and 3, and later on you have -5 and -4. So clearly this doesn't work. So the first option is not working. Let's try the next one. So A equals to, it says A modulo B, and B equals to A plus B, B equals to A plus B, and A equals to A over B, right? So let's again run this as well. Again, you see 2 and 3, but later on it becomes 0 and 5. So this doesn't work as well. So let's try the third one. C equals to option C, which is A equals to A plus B, B equals to A minus B, and then A equals to A minus B, right? And now let's run the same thing again. Yeah. So now you see A equals to 2 and B equals to 3 initially, and then later on became A equals to 3 and B equals to 2. So these numbers have got swept. And so the correct option is obviously option C. So now let's discuss in more detail what is happening by looking at it one step at a time. So I'll again stop the screen sharing and start my whiteboard. And hopefully you all can see my whiteboard while I'm doing it in here. Okay, so let's get rid of these. I don't know how one can do that. Let me just figure that out. Okay. So let's got rid of everything. So I have a clear space, and let me start writing. Let's go through the first option, right? So let me see what the first option was. So it's A equals to A minus B. A equals to A minus B, followed by B equals to A minus B, right? And then B equals to A minus B and A equals to A plus B. Right. So, okay. So let's start with this example where I start with, I think A equals to 2 and B equals to 3, right? So let me just confirm, just check once again. Yeah, A equals to 2 and B equals to 3. So A equals to 2 and B equals to 3. So let's see what's happening in here. So here in the first statement, the value of A is changing to A minus B. So this is what it's, let me change the direction of the arrow in here just to be correct. So this is the value of A that it is changing to, right? And now later on B is now getting changed to what the value of A was. So now the value of A actually changed to A minus B. That that is the original value to which it got changed to. So let me do that. So the value of A here got changed to A minus B. So this A has to be, this is statement 1, this is statement 2, and this is statement 3. So now this is again 1, this is 2. So in 2, you have A minus B, but A has now changed to A minus B itself. So you have A minus B, and you have another minus B from here. So A has changed to A minus B, and then you have a minus B. So what you have at the end is B getting changed to A minus 2B, where this is the initial value of A and this is the initial value of B, right? So later, in third step, what's happening is A is assigned A plus B, right? So now A is assigned A plus B, but I know what the value of A was, right? This was the value of A. So A was already A minus B. So A, which was already A minus B, is assigned A plus B, and B, the value of B has also changed, right? So you have A minus 2B, right? Because the value of B in here, you see, has changed. So with respect to the initial thing, what you have is 2A minus 3B. 2A minus 3B. So at the end, what you are having in here is you have A, which is changing to 2A minus 3B, and B, which is changing to A minus 2B. And certainly this is not getting swapped. So let's put in the values, and you can see you have 2. So for this, you have 2 minus 3 times 2, which is 6. So you have something like a minus 4, right? Because A was 2 and B is 3. So 3 times 2 is 6. So A is 2 minus 6, which is 4, minus 4. And similarly here you will have 2A. 2 times A is 4, minus 3 times B is 3 times B is 9. Sorry for my bad handwriting, I'm using my mouse. So you have something like minus 5. Right? And I think this is what we were getting in the code itself. Let's see. Yes. So to put these values, you can also start with values, substituting these values right from the beginning instead of me doing it at the end, which can seem a little bit complicated to initially start with. So let's also do that as well. So let's do that. So this is an alternating native way of saying that this is not going to swap the numbers, right? So let's see. So A got initialized to change to value of a minus b. So 2 minus 3, a is minus 1. So a got changed to minus 1. It's 2 minus 3 is minus 1. Now later b. I think this will be a bit simpler for anyone to follow if you found difficulty in the previous way of explaining things. So a minus b, so it's 2 minus 3, right? So let me also break this a little bit for you to follow easily. So you will have 2 minus 3, which is minus 1. Similarly, if you have b, let's see what you will have. You'll have a minus b. So a is already minus 1 and minus b. And b is, to start with, the value of b is 3. So you'll have minus 3. So minus 1 minus 3, right? So you will have something which is minus 4. That is the value of b. And now let's go to the third statement where a is changed once again, right? So it's a plus b, so a was minus 1 and plus b, so b is minus 4. So what you have at the end is minus 5. And this is exactly what I think we got it in here as well, right? So the same thing. So you see the numbers are not getting swapped in this specific case. So let's go through the second option as the other option as well, which is let's see what are the three statements. The next one, let me write the values of a and b once again, just so that it becomes easy for you to follow. To start with, you start with a of 2 and the value of b, which is 3, right? So let's now have, let me write down the statements that are there. So this is a equals to a modulo b. So this is the first statement, a equals to a modulo b. Next statement is b equals to a plus b. And third statement is a equals to a over b. Right? So let's put the values in now, and now you can see then what's happening in here. So here you see the value of a, which is getting assigned 2 modulo 3. So 2 modulo 3. So if you have a 2 modulo 3, what you will have is the, if you are dividing 2 by 3 and you get the remainder, so remainder is 2, right? So that's what you have in here. So the value of a remains the same. From 2 it gets changed to 2, and now the value of b, let's see, you have a plus b, so you have a 2 plus 3, because the value of a is 2, so you have 5, and then the value of a is again changed to what? A by b, so you have 2 over 5, which is if these are decimal, not decimal points, but these are integers, so 2 by 5 will give you 0. So at the end, you have something like a equals to 0 and b equals to 5. And obviously then this doesn't swap your numbers. So let me now go to the, oops, sorry. Let me now go to the next example. Let me also write once again, a equals to 2 and b equals to 3. Sorry, not the example, but the next option, which also happens to be the correct option as we have seen already in the code. So we can demonstrate that again. So a equals to a plus b. Let me write the statements in here. Now what is statement 2? Statement 2 says B equals to A minus B. And statement 3 says A equals to A minus B. Right? So let's see what's happening in here. Right? So in the first case, let me try the numeric values first, and then we will also try the algebraic one for the one which I was showing you earlier. So let's see what's happening. So here you see the value of A, which is getting modified to A plus B. So it's 2 plus 3, which is 5. Your value of A is here 5, right? And now let's see what the value of B is. It says A minus B. So A is now 5 and B is 3 because it started with 3. So, right? So now the value of B is 2. And now the next statement is A. So A is changed once again to A minus B. So now A is 5, as you see from the last statement, and minus B. So B is now 2 because B has been changed in the last one. So you see this is 3. So at the end, what you are having is A equals to 3 and B equals to 2. So you have A equals to 3 and B equals to 2. And this is exactly the opposite values of what you have started with. A equals to 2 and B equals to 3. So what this means is that this procedure has swapped your two numbers. So let's now also show you algebraically how this or why this is happening. So let's see what is happening in here. So A, you see, is getting changed to A plus B, right? So this is the new value of A. So later on, when you are doing A minus B and assigning it to B, what's happening in here is this A that you see in this statement. I hope you can see my cursor. If not, please tell me. You have A minus B. So this A, as you can see in here, you can is now replaced by A plus B. So you have A plus B and you have a minus B, right? So this minus B and plus B, this minus B and plus B cancels. So you have A. So B now gets the value of A. And now similarly, let's evaluate the next statement of A. So what happens in here? You see in this specific case, rather in this specific statement, A, the value of A was previously just before this was A plus B, and from some that you subtract B. So you have subtracting B, but B has now been changed to A, right? As you can see in here. So you do a minus of A. And so what you are left with, this minus A and plus A will cancel out. So what you are left with is B. So as you can see at the end of these three steps, B, the value of B gets same as the value of the A that you have started with. This is the initial value, and value of A gets changed to this value of B that you have started with. So this is why the statement that you see in option C in here was the correct statement. So let me just stop sharing the screen. So this whiteboard is now unshared, and let me go back to what we were doing, right? So let me open VS Code. Where am I? Yes. And let me take this to one corner. Right. Okay. So this was a long question to answer because it was detailed, and please make sure that you understood every bit of it, and we can now proceed to the next one. But please stop me and ask me questions if you have any doubt on regarding what this is. Okay, so now let's go and write this next question. It just asks for the output of the program, right? So let me again, as usual, I'll just write the code, and then we will discuss why we get the output that we will be getting. So x equals to 1, y equals to 3, right? Now let's see, int t equals to x. So let me get rid of all this. We have int t equals to x. I don't need this define as well, so I'll get rid of that as well. So int t equals to x, and then you have an x equals y equals e, right? And let's have a printf, then printf %d space %d slash, and let me give a slash n as well. It's totally optional. Just want to have a new line, and then you have x comma y. And then since it's an integer, you return 0, right? Okay, so let's run this code. So you have 3, 1. So the correct answer is B, which is 3, 1. So now we have got the correct answer. Let me see, let me explain why you are getting this, right? It's not just getting the correct answer, but the rationale, which is more important, right? So let's me again go back to the whiteboard and stop sharing my screen, and then we will come back. Okay, so hopefully my whiteboard would be coming up pretty soon. Yeah, here it is, my good old whiteboard. So let me take this to the region where I'm discussing. Now I'm going to discuss the next question in here. Okay, so let's see what were the statements one after the other. Let me write that down. So you have x equals to 1 and y equals to 3. So x is assigned the value of 1 and y is assigned the value of 3, right? Okay. Sorry for the bad handwriting once again. Let me correct it. I'm just using my mouse to control this, so it's a bit tricky for me. And then t is assigned the value of x, right? So now the next statement is t. This was statement 1. Let's now go to statement 2, where t is assigned the value of x. So t, that would mean that the value of t, so what is same as the value of x at this point, so the value of x is 1. So t is assigned the value of 1. Now let's go to the statement 3, the next statement in the code. So this also clearly demonstrates why C is sequential, because it follows one line at a time from in ascending order of their line number, right? So now you have x equals to y, so x is assigned the value of y. So at this point, the value of y is 3, so the value of x is 3, right? So now let's go to the next statement. The next statement says y is assigned the value of t. So now y is assigned the value of t, right? And the value of t we know at this point is 1. So I'll put this as 1, right? So now all the statements have ended, and now we are printing x and y one after the other, right? So let's see at the end, what is the value of x? The value of x is 3, and yeah, this is a very bad handwriting. Value of x is 3, and value of y is 1. So the final result when you print x and y one after the other is 3, 1. And hence you get that answer from the compiler. So let me now stop sharing and start with my screen share. And please interrupt me whenever you encounter any doubt. If not, then let's go back to the final question in this series, which is question 10. And let's see. So just like before, what I'm going to do is I'm going to type this entire thing, get the result, see what the result is, and then I'm going to discuss why you are getting what you are getting. Same rationale as before. So I have a sum which equals 3 plus 6 by 2 plus 6 times 2 semicolon. Right. Okay. So 3 plus 6 over 2 plus 6 times 2 for printf. I missed the comma in here, and I think this is good. So let me run this. So I have 18 as the answer. So let's see why this is 18. So this follows the rule of precedence of operators, and this is the same as what you'll have in mathematics, and perhaps you have done in your elementary or middle school, not elementary but middle school maths, that you have division which is done before multiplication, and after multiplication you do addition, right? So and then you do subtraction. So you have division, multiplication, addition, subtraction. So that's what is followed in here. So the first thing that you evaluate in here is this 6 over 2 and 6 times 2. So this is what is happening in here. So the first thing that you evaluate is basically 3 plus 6 over 2 is 3, right? And 6 times 2 is 12, right? And then once you have done this, you do the addition. So it's at the end that you do the addition. So now for doing the addition, what you do is you just add the numbers together. So 3 plus 3 is 6, and 12 plus 6 is 18. So you have 18, and you do it from the left. So what you do actually is 6 plus 12, and that's equals 18. So this is the rationale, and that's why you get 18. And I hope you can see what here is what I was using to show this. The correct answer is 18. So this is it for assignments from week 2, and I guess this was a fruitful exercise for you, and you are now well equipped to go and explore the world of C and also answer the questions that are there in this current assignment. And then we again meet in the next session. Until then, let's say bye and have a nice evening to all of you.